Namaste. My name is Mayank Gandhi, a student of Chemical Engineering Department studying at BMS College of Engineering. Today I am here to present on the topic of PVT behavior, phase diagram and properties table. Now let's begin with an introduction. The PVT relationship describes how pressure, volume and temperature together can help us define the state of thermodynamic system. Phase diagram helps us map the region where solid, liquid, and vapor phase can exist, while property tables help us provide essential thermodynamic data used in calculation. Now let's define what is pressure, volume, and temperature. Pressure is defined as the force of 1 Newton acting on an area of 1 meter square, and its SI unit is Pascal. That is, 1 Pascal is equals to 1 into Newton upon meter square. Now, let's define volume. Volume is the space occupied by matter in three-dimensional. Now, let's define temperature. Temperature is the measure of hotness or coldness of body with respect to freezing point or boiling points of water. Now, let's move on to pressure versus volume graph. Here, the pressure versus volume graph are given. Now, let's move on to isobaric process. Iso means same. Baric means relating to pressure. So, we can conclude something like same pressure. So, here in isobaric processes, the pressure remains same. Volume and temperature changes or are variable. Now let's move on to isothermal process. Here also same thing. Iso means same. Thermal means relating to temperature. So same temperature. Here pressure and volume are variable but temperature is constant. Polytropic processes. The processes which follow an relation that is PV raised to n equals constant where n is the polytropic index. Now let's move on to adiabatic process. Adiabatic process is process that occurs without the transfer of heat from surrounding to system or from system to surrounding. Now let's move on to isochoric process. As the name suggests, it's relating to same pressure. So the process in which pressure changes and temperature changes but volume remains constant. Here is the definition of isobaric, isochoric, isothermal, adiabatic, and polytropic processes. Take some time to read. Now, let's move on to pressure versus temperature graphs. The solid phase can exist at high pressure and low temperature, and its boundary, that is, this boundary, is known as melting curve, where solids melt into liquid or liquid freezes to solid. Now, the liquid phase occurs at moderate temperature and moderate pressure. The boundary between the liquid phase and the gas phase is known as the vaporization curve, where liquid turns into gas or vapor, and vapors condenses back to liquid. The gas phase. The gas phase exists at high temperature and low pressure. The solid gas boundary is known as sublimation curve, where solids directly convert to gas or gases directly convert to solid. Now let us understand what is critical point, triple point, and supercritical fluid. The critical point is the temperature and pressure beyond which the solid, liquid, and gas phase cannot be distinguished and it merges into one phase known as supercritical fluid, and triple point is the point where solid, liquid, and gas phase are in equilibrium. Here is the information on P versus T diagram. Take a time to read. Here is the information on critical point, triple point, and supercritical fluid. Now, let us move on to property tables. Property tables list value of important thermodynamic properties such as specific volume, internal energy, enthalpy, and entropy at various temperature and pressure. This table helps in finding unknown properties when one or two parameters are given, making them essential tool for thermodynamics calculation. Thank you. Presented by Mayank Tanti, USN 1BM24 CH035.